Hi everyone, a warm welcome to the second webinar on steel wire rope here at Eindhoven, the Clean Room Cranes office with a nice back view on their workplace. Today will be the second webinar in a series we have this year. A couple of weeks ago we had the first one on the basics of steel wire rope with our expert Alan Ballman, and he will guide you today to high performance ropes and rotation resisting ropes. So he will guide you during the next 40 minutes. Some things, you're all mute. If you have a question, please type in the chat functionality and we will do the question and answers after his presentation. So we have about 15 minutes for that. This session will be recorded and we will send it to you afterwards, as well as some of the slides, or maybe all the slides. I think we do all the slides. Not all the questions can be answered, but will be done afterwards. So let's switch to a little bit of introduction. Who did not join the last time? We're part of the Axel Johnson International Company, which is a privately equity held company that acquires industrial other companies. And they have 6 strong business lines, as you can see. And on the left side, you see that we are operating on the lifting solutions part. And well, I think you all are aware of one of those brands in this sheet. We operate as a group of companies with a strong local brand and presence. And well, these are our brands in Europe. And then we have a final slide, and all the companies, as a group, we are Europe's leading steel wire rope and lifting solutions provider. And as you can see, we have a big coverage in almost every country in Europe, even in Canary Island, which is really nice. And yeah, never been to there, but maybe next time. So this is just a small introduction about the company, and I think you all want to know more about Alain's presentation. So I hand over to Alain, and I wish you a nice presentation.
So very warm welcome from Alain Ballman, and well, I'm a Flemish Belgian, and I'm well 35 years now in, let's say, the same company, let's say Menens Certex. Yeah, I'm doing investigations, advice, climb into cranes, even if I'm 61 now, doing reports. We have a laboratory to investigate on steel wire ropes and so on. So if you have a question, just call us. We do our best. These are the subjects we're gonna tackle in this webinar. For those people who didn't see the first presentation about the basics, we just rehearse a little bit what we saw last time. If you really want to see the first webinar, you just click on the link, or we send you the link, and you can see the first webinar. It's basically about steel wire, wires, ropes, and constructions. Yeah? So we're gonna elaborate on high performance ropes today. What is the difference with the general purpose ropes we saw last time? The advantages of these high performance ropes, the applications, yeah. And then second chapter is the rotation resistant ropes, a completely different kind of rope. What is it? Why? Classifications and applications. And then if you have questions about things going wrong on your crane or what, you just tap it into the chat, and we do our best if we can after the presentation to answer your questions immediately. If not, we're gonna do it later on. This is just to tell you also there will be next webinars after the summer. We're gonna talk about inspection and discard of ropes, magnetic rope testing. There will be a separate webinar coming up for rigging arrangements, about sheaves and drums. We're going to do a special webinar about lubrication of your rope. and end terminations. So at your service also for other coming up webinars. Okay, let's start again with what we saw last time. A little bit basics, let's say. This is how normally a wire rope looks like. You have a rope which consists out of some strands, 6 or 8 or more. And in these strands, you have your separate wires. If you look on the right side, you have the outer wires, the outer wires in one strand, which come into contact with sheaves and with your drum. Inside the strand, you have the inner wires. You see them in red there, yeah. And in the center, in each center of your strand, you have the center wire. So 6 or more from these strands are surrounded, surrounding the core wire. So there is an independent wire core rope inside your 6 strands. Yeah. So we explained last time how a wire rope is made. We do that in 2 steps. The first step is making strands. So here you can see on the machinery the stranding, and then we put some lubrication into the strand. Yeah. And the second step is that we take 6 or more strands. Yeah. We put it on another machine, and then we do the closing of the wire. So we put 6 strands around a core. Yeah. And you see the preformation. The preforming is the helix we do with each strand before it goes into the knot, so that the preformation makes that the rope will be eased and will be flexible. Yeah. So general purpose ropes, like we explained last time, generally often used, very often used, are 6 strand ropes. Like you see here, you have the 6x36 Warrington seal with the independent rope core on your left side, or there are some guys who prefer a fiber core, so let's say a man-made fiber core inside, which will have the advantage that you can have inside your rope a certain amount of grease. So there will be a greasing coming automatically during your lifetime. And you see the advantages of the steel core, disadvantages of a rope of plastic core, but we explained that last time. You also could use 8-strand ropes. These ropes have 8 strands on the outside. You see there's a little more complicated inner wire rope core you need then to fill up this space. But you have the advantage that the rope is much rounder. Yeah, it comes more into contact with your sheaves, so you're going to have lower contact pressures, less wear into your grooves, and a more flexible rope. So it's normally going to last longer. So keep that in mind. 8-stranded ropes, more flexible, and a little bit more expensive, of course, because it's difficult or more difficult to produce. You need more different kinds of wires. So, but it's always interesting to have a longer lifetime on your crane. And then we talked about the rotation resistant ropes. These are ropes where the core is inverted. And we said every rope which has more than 10 strands on the outside would normally be a rotation resistant rope, yeah? A non-rotating rope, or as in French, anti-giratoire. So the core is inverted, yeah? And this is especially useful for very high hoisting, like applications in tower cranes, mobile cranes, or if you only have one part hoisting, then you normally need a rotation resistant ropes. And then we had this overview where to use, let's say, the general purpose ropes on winches, 6-stranded or 8-stranded. On overhead cranes, you see 6x36 or 8x36, some more flexible ropes. On container cranes, you can see the 8 stranded ropes, which last longer on container cranes. You have a special kind of rope for elevators. Yeah, it's 8x19 inch steel with dual tensile, so with two different wire classes with the soft wires on the outside, so that you don't have wear in your elevator machinery. And at the right side, you have the tower cranes with, let's say, the non-rotating, rotation-resistant ropes, mobile cranes. And if you need advice where to use what, just call us. We give you an idea what is useful on all your different applications. Then we explained also the difference between left and right hand ropes. We explained that there are two different kinds of lays, ordinary lay and Lang's lay. Here you can see the explanation. So you see right and left hand lay and Lang's and ordinary lay. Yeah, it depends on which lay you have on the right and on the left, but also look at the lay in the strand, because strands can be also left and right-handed strand, and then you can close them up in ordinary or Lang's lay. We explained why you really need right and left-handed ropes. If you put a load on 6 or 8-stranded rope, this rope will open up, so you get, let's say, a torque or a moment in your rope. And the more load you put on the rope, the more torque you will get, the more rotation you will get on your rope. So your load will turn. And that's why in some applications you need a left and right hand rope, so that these moments of the left and the right rope, they end up together as 0, and then your load will be straight, or we stay straight. And that's why in some applications you need left and right hand rope combined in a set, so that you can easily work. You also need left and right handed rope because you have drums, and these drums, they have left or right cutted grooves. Yeah, and on left grooves you normally need a right-handed rope and the other way around. So that's why you really need in some applications right and left hand ropes. Yeah. Okay, now let's talk about high performance ropes. What do we mean with high performance? I explained, but you see here on the left side, you see the general purpose ropes. So standard 6-strand, 8-strand ropes. The non-rotating ropes like 19x7, so where the core is inverted, or the 35x7. This is a kind of, let's say, old type of non-rotating, rotating resistant ropes, with a lot of strands on the inside and, let's say, 16 or 18 strands on the outside, core inverted. Yeah, it was the first type of non-rotating rope invented for about, let's say, 100 years ago. So this is all classified as general purpose, very often used. They do the job, let's say, but if you want to have something special, yeah, then we could advise to go to the high performance. And what is high performance? Well, you see in 6-strand ropes, we compacted the outer strands. You don't have round wires anymore, which come in contact with the sheaves or with the drums. So they are die-formed. Yeah, each strand is compacted, and then we make from these compacted strands, we make a 6-strand compacted rope. We could do the same in 8-stranded compacted, as you can see there. So then 8 strands are compacted, and we have a 8-strand compacted rope. We can go on further doing plastification. So the 8-strand plastic infill and compacted. This means that after we have manufactured the inner core, yeah, we plastify the inner core, let's say, and then we put 8 strands into this plastic layer, and then we have a plastic infill. Yeah, we could do it with round wires in the strand, or we could do it with compacted, as you see there on the right. More specialized ropes will be 10-stranded ropes with 10 strands on the outside. So you're going to have a rounder rope, stronger, and also with the plastic infill and also compacted. And the rotating resistant ropes, we call them high performance if they have 16 strands on the outside. Eventually, this compacted, yeah, in Lang's lay on the outside, let's say, and also if you want with a plastic infill, yeah. So this is the big difference between high performance ropes and general purpose ropes. So what are high performance steel wire ropes? Well, we're going to show you what and how. We have the plastic infill between the strands and core. We have compacted strands, yeah. Sometimes we have hammered strands, I explain later, and sometimes you can go for double parallel ropes, which are much stronger and used in special applications. So first of all, I'm going to talk to you about the plastic infill. If you have this plastic layer between your rope core and your strands, that means that you don't have any more internal wear. So there are no more contacts between the outer strands, wires, and the wires from the steel wire core. Yeah. So this will prevent, let's say, wear coming from the inside of your core. So there will be no more contacts between strands and strand cores. It keeps the grease, the original grease from the wire core, it keeps it inside. So don't worry about greasing or things happening inside your rope. It will stay there till the end of his lifetime. It keeps water and dirt or mud out your wire rope, so don't worry about water applications, so you won't get rust from the inside. It keeps all dirt outside. And it will increase your stability of the rope. If somebody would try to open up this rope, then the plastic layer will prevent from opening and will keep all the outer strands in place. If you want to re-grease or lubricate your rope again, you just have to re-lubricate or grease your outer strands. So you don't need as much grease or oil to lubricate your rope again. Yeah? That's what about the plastification. Yeah? A second high performance rope making is the compacted strands. You can just compact your strands. As you can see there, you see normally if you make your strand, you have round wires at the outside. Well, you could do decompactation. You just put the strand into a compacting roller machine, and they will end up with compacted strand for your outer stranding wires. You can see that you have a higher breaking load. There is more steel into a given diameter, yeah. And you're gonna have much more contact because the rope will be in the end much rounder. So you see you have more square millimeter of contact with sheaves and with drums, which give you a very lower contact pressure, which give you lower wear on your rope, but also lower wear on your sheave groove and on your drums. Very important, because sheaves and drums will cost a lot more than your rope. Yeah, you have a higher flexibility with lower stress. Yeah? You have a smoother wearing surface of the rope between drums, sheaves, but also if you have a multi-layer, also between the ropes themselves. Huh? If you have a broken wire due to fatigue, yeah, then this broken wire, due to the form of this deformed wire, the broken wire will break, but it will normally stay into the strand. So you have one wire doesn't work anymore. But yeah, if you have a round wire in the old construction, this wire will break and it will come out of the strand. And then when this wire out of the strand goes to sheaves or on your drums, it will be in touch with a neighboring wire. Yeah. And so, yeah, eventually it will disturb his neighboring wires, having 1, 2, 3, and more wire breaks. So this stranding will have a lot of advantages, just staying for one wire, and it's going to be a longer lifetime, so it won't disrupt the structure. As I told already, so there will be no knotting, let's say, between the rope on multi-layer drums. That is the compacted strands. A third manner of making ropes more round is the hammering. You have a certain compacted rope which could be hammered, and then you see that the roundness of these ropes are more round, getting more round, and the rope will get more flexible in certain applications. The outer strands are compacted and then hammered, so you have more contact with sheaves, more contact with drums, and also more contact between the different layers on multi-layer drums. Yeah. The cable is even more robust, and you have more metallic metal in your section, so the rope will be much stronger. Yeah. Another idea about making ropes more stronger, more flexible, is the double parallel 8 and 10 strands. What do we mean with that? Well, normally ropes in 8 strand, as you see on the left side, have a 6-stranded inner core. Yeah, we could double it up just like 8 strand on the outside, but also 8 strand on the inside, so that every strand will be laying into 2 underneath laying strands. We could do it even with 10 strands, so you have 10 strands on the outside, and then you have the plastic layer, but on the inside you also have 10 strands which are underneath the 10 outer strands. If you look on the right side, you have this typically 10 strand with a double plastic layer. So you have first a plastic layer between the outer strands and the core, but as you can see in the core, you also have an extra plastic layer which prevents that things will open up, and which keeps all properties and all grease inside. So these are the double parallel and 10-stranded ropes we advise in some applications. So let's say, what are the advantages again of the high performance rope? It will give you an increasing braking force of about 30% stronger. So look that up, because in some applications you go down in diameter, yeah, which could have a lot of advantages for your sheaf diameter or your drums, yeah. Or if you just leave it like this, you have a rope which is 30% stronger, which give you a more higher safety factor, let's say. For the increasing performance, you normally have a longer lifetime. You could double, triple, or depending on the applications. You will have more cycles, because when I explained all these different compactation and plastic infill and the grease which stay inside, you could do more tons, yeah, without any problem. So you don't have to worry what is happening inside. You just look at the outside. You wait till you have, let's say, the fatigue coming in the outer strands. You have more stable diameters, because when this rope is rounder and when it's compacted, you will go down in diameter reduction, but just by wear coming on the outside of your strands. In general purpose ropes, yeah, you have a lot of air into your or between the strands, yeah, and this will give you from the beginning a diameter reduction. So these high performance ropes, they will stay a lot longer on the same diameter, so they don't go down and down and down till the end of their lifetime. You're going to end up with ropes which are in diameter almost the same as from the beginning, and this will give you a lot of advantages for wear in your grooves and on your drum. So less wear on ropes, less wear on sheaves and drums, because you have lower contact pressures. More secure, yeah? So there will be no opening or trying to open up the ropes due to rotation, and you could have higher fleet angles on your installation. You know, the fleet angle rope coming into or under a certain angle into your sheaves. This will prevent opening up the rope. Yeah, you can allow more wire breaks before discard. As I explained, one wire which has a fatigue problem will stay into the strand. So don't have to worry what's happening inside. You only look on the outside from your rope. Everything else is protected by the plastic layer. I just have to mention this little note. Yeah, you're going to have big advantages with longer lifetimes, more cycles, if the grooves in sheaves and drums are correct. So if you use high performance rope, yeah, there is no more possibility for this rope to go down in diameter quickly if your sheaves and drum grooves are not correct. Yeah, so you're going to have no good result if you're just using these ropes on very bad grooves and drums. We had some exercises like this. Okay, you propose some high performance ropes to a client, yeah? And he says, oh wait, I have a lot of problem with this overhead crane there. You put it on there and let's see if things work. Yeah, we're not going to have a good result if the grooves are badly from shape, if they are worn in. Yeah? So then this kind of high performance rope won't have the possibility to get quickly into a thinner diameter, and you're going to have a lot of wire ropes immediately coming on the outside. So don't put it on grooves or sheaves which are completely worn out. Okay, let's talk something about price in this high performance. Well, I just make some table here with some price indications. Okay, you have 6 strand. If it is, let's say, for a price of 100, you can have general purpose ropes in 8 strands, which be about 20%, yeah, in price higher, yeah. But you see, the strength will be also about 10% higher. 20% sometimes. Well, if you go to high performance, 8 strands with plastic infill and compacted, let's be honest, it's going to be double price. Yeah, it's going to be 20%, let's say, more in strength. Yeah, but the lifetime will double. Yeah, as you can see. Even if you go to high performance 10 stranded, price will be about 240 or something, with more strength in your rope for 35%. Even with the double plastic compacted 10 stranded, you're going to see that you end up with 40% stronger ropes. Okay, with the price which is 2.5 times, but look at the lifetime. Yeah, it's going to be 3 times or 4 times. Believe me, if the installation is correct, you're going to be surprised how long these ropes will last on your installation. The gain is the installation cost, because you're going to buy a much pricier rope, but as you look into the table there, it will gain you 1 installation cost, 2 installation costs, 3 installation costs. So your assembly cost, you're going to have less downtimes. Yeah? Your wear of the grooves will going to be minimum. The only fatigue you're going to have is on the outer strands, so your core will stay intact. You need fewer lubrication on the external strands only. And if you have an accident, accidents do happen sometimes, you support the overload because you're going to have stronger ropes anyhow, and perhaps the rope will survive because it has all these different properties inside the rope. And as you can see there in the initial cost and the effective cost, you can see when buying a high performance rope, you're gonna end up with only one installation instead of general purpose ropes, which won't last as long, and you're gonna end up with 3 installations. So take care about the cost of your installation, and anyhow, the high performance ropes will do the same job with a longer lifetime and only with 1 installation. So I prefer high performance ropes, there where the installation takes a lot of time, a lot of money, a lot of workforce. Take it in very important installations who normally will be a disaster if you have downtimes there. If you can planify your changing of the ropes carefully, then I would advise to use high performance ropes. That's the first chapter. Now let's talk about rotation resistant ropes, non-rotating also mentioned, and in French, anti-giratoire. What is it? Why do we need these kind of ropes? Constructions. I explain about the advantages in Langsley and the classification. What is a resistant, rotation resistant rope? Well, I already explained it. It's a rope where the core is in the opposite direction than the outer strands. And it is used in one-part reeving systems. So if you have only one part of a rope coming down, for hoisting, and for great lifting heights like on mobile cranes and tower cranes. Even at very high loads, you won't have a rotation moment in this kind of rope or torque, because if you load this kind of rope, the outer strands would like to open up, but the inner core is closing up. So then you have a calibration from the rope itself, so it won't have a moment or a fatigue. So rotation resistant ropes, 6 and 8 stranded ropes give under a certain load a rotation moment, torque, due to the helix form from the outer strands. That means that in, like I elaborate on that there, you see in a block with 1 sheaf or in a block with 2 sheaves, 6 and 8 stranded rope, we give on each strand, we give a rotation, And this means that all these rotations are in the same direction. So if you put a load on your block, the block will turn. To prevent this, so you normally need to install a rotation resistant rope. So this rotation resistant rope, each strand will have no moment and your block will stay steady. With rotation resistant ropes, you have 2 kinds of rotation resistant ropes. If the moment or if the torque is 0 or almost 0 till about 80% of the minimum braking load, we speak about the rotation resistant ropes, a 100% rotation resistant ropes. If it is almost 0 or only till 40% of the minimum braking load, we speak about a semi-rotation resistant rope. I explain this later. How could you identify if you really need a rotation resistant rope or not? Well, there is this certain formula you can use. You can make this formula work to decide what would be the maximum lifting height. I explain quickly. If you have a 6 and 8 strand rope in a certain constellation on your crane, you put some of these different figures into this formula. You can see there S will be the effective spacing between the different part of your ropes. So normally these are the diameter of your sheaves up in your crane or down on the block. You could also make an average of both top and block sheaves. Yeah. So you put that in the formula. Yeah. Then you have the diameter of the cable, that's little d, you put it in the formula, and then you have two constants. One constant is C1. C1 is the, if you have even parts in your reeving, if you have even parts, and C1 is if you have odd numbers of parts in your weaving system, then you need the other constant. And constant number 2 is depending on the type of cable. 6-stranded with fiber core, 6-stranded with inner wire rope core, 8-stranded with inner wire rope core. You put all these into the formula, and then perhaps you end up with, let's say, 20 meters. That means that your block will be steady till you drop it down to 20 meters. If you go down to 30 meters, then automatically your block will turn. So the parts will turn into one another, you can't work anymore. If you need more maximum lifting heights, then in this situation, if you excel the lifting height coming out of the formula, then you have to use a rotating resistant rope. Yeah. In that case, 6- and 8-stranded ropes will only work till, let's say, 20 meters. Look at the formula, there is no load, there are no kilos or watt into, so it doesn't depend on your load, it is just a constellation with the different parts in your block. Rotation resistance ropes, let's repeat, it is what? Core is reversed, yeah? Why should we use it? You use it instead of where you have normally torque in 6- or 8-stranded. You have semi-rotation resistant and rotation resistant ropes. It depends on the number of outer strands, outer wire strands, and the construction of the core. The one on the left side we call a semi-rotation resistant. You see all the different strands are the same. Yeah, you have 12 strands on the outside, and you have 7 strands on the inside reverted. If you look at the one construction at the right, this is a really rotation resistant. Look at the core, it is very complicated. You have 16 strands on the outside. There the moment will be 0, and the other, the semi-rotation resistant, your moment will not be 0, and certainly not till 80% of the minimum breaking load. So where to use? You use it in one part hoisting, or you can use it in high lifting. Just take the formula, count what you need, and then you normally will have an idea if you need to use a rotation resistant or not. Where not to use rotation resistant ropes, where you have shocks. If you have shocks, yeah, you're gonna destroy the core inside, yeah. Don't use them if you have too small sheaves, because your core will be damaged, as you can imagine. If you have this kind of rope going around a very small sheaf, yeah, you're gonna damage the core, which is an inverted inside, so be careful. And don't use it normally because you think you need a stronger rope than a 6 or an 8 strand. If you look into the specifications and you have a rope in a certain diameter, say, okay, I need a rope which is stronger. Don't just look at rotation resistant ropes. They're gonna be stronger anyhow, but it's gonna be core damaging, or it's not gonna work on too small sheaves. My advice is also to use Langsley ropes, Langsley on the outside. So as you can see there on the picture, yeah, Langsley ropes. So you have a right-handed rope on the outside, but look into the strands itself. You have also right-handed wires, yeah, in your outside layer. It's going to be a more flexible rope. If you have Langsley ropes, you're going to have a better and longer lifetime, certainly on multi-layer drums. And rotation resistant ropes are oftenly used on multi-layer drums, in many layers, one about the other. So I would give now you an idea about all the different rotation resistant ropes there exist. You have here also an idea about what we call semi-rotation resistant ropes. there the moment or the torque is higher than zero, could be higher than zero. The problem was years ago that somebody really ordered or wanted to have a rotation resistant rope, yeah, and they sold the guy a semi-rotation resistant rope. So therefore we have this classification, and that's why the ropes with a very complicated inner rope core are now classified non-rotating class 1 or A in England, or the non-rotating class 2 or B if you have a semi-rotation resistant. Let's say that there is a very great difference in working with these ropes. Look, real rotation resistant ropes, they can be used with a swivel on your crane. The semi-rotation resistant ropes may normally not be used with a swivel because the inner core is inverted, okay, but in some cases you're gonna end up only loading on the inner core. So never use a swivel with semi-rotation resistant ropes. It's very important. That's why if you ask at our companies a rotation resistant rope, just look on your certificate to see if you have a class A 1 or a class 2 B, yeah, classification for your rotation resistant rope. I have an overview from all the non-rotating anti-giratoire rotation resistant ropes which are on, let's say, the European market. Look, they're gonna sell you all this type of ropes as a rotation resistant rope. Look at the different number of outer strands. You have there 16 outer strands, 18 outer strands, 15 outer strands. There are even with 12, let's say only 12 outer strands, yeah. 15, 16, 14. Huh? The most important thing is how does it look on your inside? And you're not going to see it on the inside. You're never going to see the inside. But look at the different type, different constellations of inner rope core. Yeah. So I say the number of outer strands 16 and the number of inner strands 19 will give you a good quality of a good non-rotating or rotating resistant ropes. But as you can see with all these different kind of cores, yeah, prices can be very different, and also torque or moment which end up in your blocks and so can be very different. Price will be different, but your rotation resistance will also be different. So if you have doubt about this, we can give you an advice what kind of really rotating resistant rope you need. Anyhow, rotation resistant ropes, they can give you some problems, and many times the block is also turning with a rotation resistant rope. Where does this come from? Well, there's a certain rule. If your block is turning without load on the block, your block is turning, then you really have a crane problem. This means something is wrong with the grooves of your sheaves, or something was wrong when you put the rope on your crane. You put a rotation into the rope, and that's why even without load, your block is turning. So I call this a crane problem. Yeah. If the block is straight, yeah, and you put a load on the block, and then suddenly your block is turning, then I call it a rope problem, yeah? Because you put load on your block and you have a block which is turning. That means that each part of your rope will give a rotation. So there is a problem with your rope rotation, so with your rotation resistant rope. Just then look at a rope which, let's say, have another type of rotation resistant, a lower torque factor or something. Yeah. So this is a rule. With no load on the block, block is turning, crane problem. With load on the block and turning, it will be a rope problem. Very important to mention also with certainly rotation resistant ropes is that normally if you have the time, you need a running in period for this kind of rope. So after installation on a tower crane or on your mobile crane, you have to make sure that the whole rope will adjust himself in diameter so that the initial stretch will disappear. Your rope will come to its exact diameter and the rope will be set. It will come to an easing point, let's say, in your sheaves in your drum. And how you can do that? Well, you pick a load of about 20% what you normally take with your crane, and you ride around. You ride around just using all parts of the rope, going through your sheaves. You do it several times, and then afterwards you do it with 50% of the load. So it's like an athlete which is making or is going to make an Olympic performance. You have to train your rope. And then if every part of the ropes are at ease, okay, then you start working with your rope. Believe me, if you do this, and not many people are doing this because they don't have time, you have a problem on your tower crane, quickly, we can change the rope. Okay, the rope is changed. Okay, we're going to work tomorrow with the tower crane. They don't have time anymore, they're working. Problem is that there are certain parts of this rotation resistant rope which work, other parts who stay on the drum. Then you go to another constellation, the crane is getting placed elsewhere and perhaps higher or lower. That means that then in this kind of work, rope is coming from the drum, which didn't work before. Then you have this conflict, let's say. But if you do this running in on your rope, believe me, you're going to have 20 or 30% more lifetime on rotation resistant ropes. This is very important. So do the running in, think about an athlete, and then you're going to gain, let's say, lifetime. And remember, rotation resistant ropes, they are more expensive, so take care. Consider doing the running in. That's it for me now. Next time, we're going to talk about inspection of wire rope, discard. We're going to make you experienced examinators of rope, or just to be certain that you can have a look at your ropes and think, okay, this will end not today. We're going to be certain that ropes are still safe to use. We're going to speak about pneumatic rope testing, so looking into the rope with magnetic apparatus. So that's another webinar coming up. Another one is the rigging arrangements for sheaves, drums, diameters, blocks, hardnesses of sheaves and grooves. Lubricating of wire ropes, when, why, with what, how many times, and so on. Okay, and all different kind of end terminations that we can put on the rope. Thank you for your attention. I hope that you looked carefully at what we explained. If not, well, you can turn yourself to the taped version, and then if you have questions, you just take contact with me or with all your different companies in all over Europe. That's it.
Perfect.
Michel.
Thank you very much, Ellen. There are some questions, and we still have a couple of minutes to go, so I will ask them to you, and if you can
Let's see what we can do.
them. Can you let us know what the disadvantages are of a double parallel stranded rope?
Yeah, if you have double parallel stranded rope, you have to take care of some fleet angles. So that depends on how many degrees you have coming out from sheaves or going to drums. We can have some problems with double parallel ropes which are not with a plastic infill, but the plastic infill will do a lot of good. So you know that the maximum fleet angle for ropes is 4 degrees. 4 degrees is a lot, let's say, huh? But normally with plastic infill, you can go to 2.5, 3 degrees left or 3 degrees on the right side. So, but it depends. It all depends on what is the situation of the groove also. And yeah, sometimes double parallel will gain you a lot of lifetime. But remember, with compacted and with plastic infill ropes, normally they will do the job. Yeah.
Perfect. Another one. Do you think that the compacted rope maybe reduce the live rope?
No. Some people have the idea that when you are compacting the strand, yeah, you're going to end up with a strand which is already fatigued. Yeah. There are some companies, I don't mention names, they don't do the compacting. They only do the hammering. Yeah, that means they make up a rope to, let's say, a certain diameter, let's say 21 millimeter, and then they compact the whole rope. They don't compact, but they hammer the whole rope. So this means that they are going to crush all the outer strands onto the rope core. And this will give you a fatigue, yeah, because you really disformed, let's say, the outer strands, and also you just put the outer strands in contact with the inner core. So there you're going to have a fatigue problem anyhow. Huh? So I prefer high performance wire ropes, which are just with compacted strands. You compact the strands, yeah, and then with these compacted strands, you make your rope. You're going to end up with a rope much rounder, compacted, but only the strands. So you're going to have a lot of advantages by using these compacted strand ropes. And it all depends on, let's say, who is the rope maker. Yeah, I don't say you have very bad companies making ropes, but everyone tries to duplicate the original, yeah, or the inventor, yeah, and some things can go wrong. Yeah? You need to have this compactation into the fingers, let's say. Yeah. Next question.
Okay, well, there are a lot of more, so
whoa.
let's say about 3 to do right now. Do you have an overview of the different discard criteria for high performance wire ropes versus conventional wire ropes?
Yeah, it all depends on the number of broken wires. Yeah, so normally higher performance ropes will start from 8 strand. 8 strand ropes give you 8 times as a number of outer wires. Yeah, so in high performance wire ropes, let's say, you're going to have a lot of more outer wires coming into contact with sheaves. That means if you have more outer wires, then you can have more broken wires before discard. And as I told you, if you have in compacted strands a wire which is fatigued, it won't come out of the strand, so it won't damage his colleagues when it goes through sheaves. So normally you have discard on a certain longer period. Yeah. Anyhow, think about the inner core, which will be still intact, or normally they will be intact. Your layer, your plastic layer, will get a certain amount of wear also, but if the plastic layer is gone, then only you're going to have contact between the outer strands and your rope core. But normally, if the plastic layer is gone, then you're also going to have some wire breaks on the outside, wear or fatigue. So normally you're going to discard your rope from the outside, and you don't have to worry about what's happening inside. Yeah. So generally, you're always going to have a lot of more advantages with high performance. Should be advantages because your rope is more expensive. Yeah.
Okay, next question from Aldrius. Are high performance steel wire ropes useful for guide telecommunication mast? Difficult one.
Yeah, in small diameters then I think you're gonna have anyhow the advantage that it won't take water inside. Yeah, but I think for mast or something, there are gonna be more specified ropes like completely stranded, one strand ropes. Yeah. Let's say cable claw. I think there you're going to have a better performance. Remember that all these 8-strand or 10-strand rope, they have a certain stretch. Yeah, if you need it for antennas or something, this kind of rope will give, I think, too much stress. Yeah, elasticity in it. Okay. There are specially developed ropes, let's say for antennas or for Auban or for things. The only thing they really need is a strength, yeah, easy to make certain terminations on it, and then there is no water problem or rusty problem on the inside. I wouldn't, if you can use, but I wouldn't really use this kind of rope. They have normally much more advantages as hoisting ropes, going through sheaves, going on drums in different layer. Yeah.
Okay, let's do another one. I think it will be the final one because of the time. Could you say us if you recommend non-rotating rope for cranes, STS, ship to shore?
Non-rotating ropes for ship to shore, normally not. You just use 8 or 10 strand ropes. Non-rotating ropes only on, let's say, mobile cranes and tower cranes.
Tower cranes, yeah.
So for very high lifting applications. Normally for ship-to-shore cranes, container cranes, use 8-strand or 10-strand ropes in left and in right if necessary, or in right, just only in right, like you see a lot. That will work perfectly. 8 stranded ropes compacted with plastic infill will do the job. Certainly on container ropes. Yeah.
Okay. Let's do one more. Why not? Why would we not always use a rotation resistant rope? What are the disadvantages of a rotation resisting rope?
Well, let's say a rotating resistant rope is, you have to take care of this rope. Yeah? It is more difficult to install, I think. Yeah, you need it in certain circumstances. Yeah, look at the different type of ropes and manufacturers. They're all going to say they have the best rope, and I'm not certain they have the best ropes. They are often used on plastic sheaves also. Yeah, there's a whole discussion about that in blocks to save a lot of loads in your block. And I know, okay, rotation resistant ropes, you're going to need them where you use the formula. If you use this formula, you count it out and you have 50 meters, but your height is more than 50 meters, then you're going to have terrible problems with 6 and 8 strand ropes anyhow. It's not depending on the load, it's depending on the height you really need. So, and if the formula directs you through rotation resistant rope, then you need a rotation resistant rope. Yeah. On container cranes, you have normally 8 or 10 strand ropes. Yeah. But if you have in your container crane up there, you have overhead crane. Yeah? to pick up, I don't know, spare parts from down there, then you're going to see you only have, let's say, a block with 1 or 2 sheaves. Well, this will normally have to be a rotation resistant rope. Yeah, but the other ropes, container or grabs or something, just use 8 strand or 10 strand high performance, plastic infilled, compacted ropes, and they do the job. We have about 99% of all the ropes in the harbor of Antwerp on container ropes. They come from Manners, and I think everybody is happy with the result. And if they're not happy, we organize a visit, we open up ropes, we analyze it, we advise it, we go further, we measure the grooves. In many, 90% of problems with ropes, I'm going to tell you it's going to be about sheaves, grooves of sheaves, drums, and things like that.
Great, thank you very much. Unfortunately, time's up. It's 12 o'clock.
Oh.
There are some questions left, but we will answer them in our follow-up email, on our email to you. You also received the recording and I think the presentation as well. You can share it with everyone. Thank you very much again. In the chat, we also have put in a evaluation form. If you have 2 minutes of your time, please fill in to improve our sessions, or not. Maybe you get a rate 10 this time. Last time it was a 9. So again, thank you very much for your time, and we will inform you also about the upcoming webinars, and they will be after summer holidays. So I think will be September, October, etc. Have a nice day.
Many greetings from Eindhoven, and till next time. Bye-bye.
Till next time.
Always
Bye-bye.
at your service. Bye.